We are now at the last section of Chapter 10. We've been looking at converting measurements to doing area and items of that nature, as well as temperature. And now we're going to finish up with volume and surface area. So our first look here is that we have a gallon of milk. A gallon of milk. Well, a gallon tells us capacity, how much it'll hold. So we're going to say it's the space contained inside the polygon. All right. So capacity. How much will it hold? All right. So in this case, this is a rectangular. I know it's not exactly, but it is a rectangular polygon. And it contains volume. So now let's look at some of the formulas that we use to work these problems. All right, so we have volume of a rectangular solid is length times width times height. And a cube is side squared. So it is a three-dimensional shape to form a solid. So what are the criteria for volumes? Have vertices and sides or edges. Is measurable. In the same unit of measurement. Okay. Now, don't get me wrong, we also have a sphere, which is a circle, and a cylinder. But all of them are contained in a shape with some form of edges and vertices in what we'll study in this shape. We're going to find the volume of this figure. We notice it's a rectangular solid. So we know that volume is length times width times height. So 3 is my height, 2 can be my length, and 2 is my width. Because we understand, that looks misspelled, not width. Sorry, I've left off the D. I said, God, it looks width. It's width. Thank you. All right. So we have a square base, and the height is 3 centimeters. So all units the same. So if we're looking for the volume, it is 2 centimeters times 2 centimeters times 3 centimeters. All right. So if we multiply that out, we have 4 times that, 3 is 12 centimeters, centimeter times cubed, because we're doing volume. And I forgot to mention that. The units of the product is in cubed measurements. All right. So here we have edges, bases, and we have an altitude here, a height, and this is called a pyramid. So a pyramid has the volume as 1/3 big base times height. Well, this means the base of the bottom, which is length times width. The only difference between this and a rectangular solid is that it has a peak. And the height is a perpendicular drawn to the base of the shape of the pyramid. So we have a visual here of a solid. And you can see that inside, right here, is that pyramid. And we're trying to calculate how much of that pyramid is not included in the volume, and therefore they come up with this 1/3. Well, right here we have the Transamerico Towers, 3,678 windows take cleaners 1 month to wash. Its foundation is sunk 15.5 meters, 52 feet underground is what it is, the base, into the ground, and is designed to move with the earth tremors. So it is more or less an earthquake building. It'll withhold a tremor, not a big serious one, but one that is normal. So we have this example here of the volume of this shape. So we have a pyramid, and we want the volume, and we said it's 1/3 big base times height. So our base is down here as the length and the width. So the volume is 1/3 times 8 inches times 3 inches times the height is 10 inches. Now they're telling us the height is there because they didn't draw it, and it would be that perpendicular to the base. So this would give me 1/3 of 24 inches squared times 10 inches. All right, so 1/3 of 24 is 8. So we have 80 cubic, oops, I put an M instead of an N, inches is the volume. Okay, nothing difficult, following formulas. We're getting an exposure. All right, so here are some common formulas for surface area. Well, let's figure out what a surface area is. A surface area is the area of each panel that forms solid. And notice here we have a circular cylinder, and we have a rectangular solid and a cube. So that means that we're looking at the areas of all of those shapes. So in the rectangular solid, we have 6, all the same measurements, sides squared. All right, 6 sides squared. And this means that whatever the side is the area of that panel. So this would be area, 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 area of the base, area of top, area of the opposite side, And you see the sides are 1, 2, 3, 4, 5, 6 sides. Okay, so that would be the surface area of a cube. Then we have that rectangular solid. The rectangular solid says that we have two of each area. So, so the surface area of a rectangular solid is the area of the top and bottom, length times width, plus 2 times the two ends, which is also length times width of those measurements. And then we have the sides. And that's also length or width times height. Sorry. Okay, this one is height because it is the sides. This one is fine. This one's fine. And then the sides are height because we're talking, this is a height and this is a length. Okay. So that would give us 2 LWs plus 2 LHs plus 2, and they mentioned it as width times height because that would be the width. Sorry about that. So we've got them all. And then the cylinder, if we have a circle on top, the area of a circle is pi squared. Then we have that cylinder portion. So if we cut it, then we have a rectangle. And this guy right here is pi radius is the length, and the height is just the height. So it is pi radius squared. So for that guy, we're going to have pi radius squared times 2 because we have the top and the bottom. And then we would add to it the area of the rectangle, which is pi radius squared for, actually it's circumference. So we're going to have 2 pi r, it's a circumference, and times the height, and that's for that. All right. So let's do some examples using these formulas. Again, keep your formulas in order so that when you take the exam, you'll have no issues dropping in the appropriateness. So we want the surface area of a rectangular solid. Excuse me. So we want the panels. So the base is going to be 2 7 times 4, because that is going to be the length times the width plus 2 times the 4 times 6, and that is the width times the height, plus 2 times, and now we have the side panels, which is the length times the height, and there you have it. So we're going to stick that in our calculator. It's pretty easy here. I'm pretty sure I haven't turned on my calculator yet. So I'm going to have 28, 24, and 42 times 2. All right. So this is going to be a 56 and a 48 and an 84. 18, because this is going to be 10, 18. So that's going to be a 13, 18. And this is in inches. That's in inches. All right. So let's look at our next example. And while I'm thinking about it, let me open up my calculator. It should come here. All right. Now, on this guy right here, it's a composite figure. It's called composite. Many shapes within it. And we have to see what we have. My calculator. Oh, I think there he is. Let me get that going because it's going to be a little more I can do in my previous one. Almost there, and I'm sorry. Okay, so let's talk about this when my calculator's coming up. We have a right angle here, the height of this trapezoid. So line here, you can see it. And where did it go? Oh, there it is. All right. Let's see. Yeah, it's not opening, is it? It will in a minute. So it's a trapezoid there and a one opposite that side. And we have here a, the width here is 7 yards. So it's like the height. And the diagonal is 25 for this plane. So this is a slant side rectangle. And we have two of those. We have a trapezoid right here. And we're going to have these. And then we have a rectangle here. Okay, so these lengths are 64, 64, and this width is 55. The height is 25. So right here we have two sides, rectangles. All right, so let's see what we can put together. And they want us to find surface area. So our surface area is going to be two trapezoids plus, because these are all area, two trapezoids plus two sides plus these sides here. This is a rectangle bottom, two rectangle plus, okay, and then we have the slant rectangle, two slant rectangles, and one top rectangle. All right, so now we're going to do our formulas. So we have two trapezoids, 2 times big base plus little base and a half. Well, I should have a half in the front. Sorry about that. 2 is 0.5 big base plus little base times the height plus 2. And on this guy right here, I had the side. So it is length times height, because this is the height. All right. Plus, this is also a length times a height. And this is, and this is a width, though. Sorry about that. That's a width times the height. This is the length times the height, two of those. Now we're talking the slant, and that is the length times the slant. And we're going to say height. And then we're going to have 1 length times width of the top. Okay, so now we're going to put in our values. So we're going to do the trapezoid. 2 times a half times the base is 55 and the little base is 7, sorry, can't see, and the height is 7. So I got that. And then I'm going to have the width times the height. So I'm going to have width is 55 and the height is 25 plus 2 times the length 64 and the height is 25 plus I got 2 slants. 64 is the length and the slant is the 25. And then I have the last rectangle, which is 64 times the 7. All right, so let's talk about our sides. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, 2, 4, 6, 8, 9. 9 sides. So we can just stick that in our calculator and hopefully it's up, and it is. Hold that thought. So let me have a little bit room. A little bit smaller. There you go. There it is. So I'm going to do a second, sorry about that, second quit. This is the home screen, and just down a moment. And we're going to clear it, and we're going to put in what we see. Again, make it just a little bit larger. I'm having no luck. All right, so I'm going to put 2, and I'm going to put parenthesis, decimal 5, parenthesis, 55 plus 7, close parenthesis, look what I did, plus 7, times 7, and close parenthesis, plus 2 times the 55 times the 25, plus 2 times the 65 times, 65, let's see, I have 255, 25, 265, well, my calculator's acting kind of strange. There we go. I'm going to put times instead of a minus. 25 plus 2 times 64 times 25 plus 64 times 7. Okay. When I do this giant math, I get 10,034. And I've made a small mistake somewhere, I think. Let me look. Times 7, 55, 25. Okay, 10,082. That's what it is. And this is in square units. And these units are in yards. All right, that was a good one. All right, here we go with an application problem. An application problem is nothing more than a word problem. So let's see what happens here. A building contractor is to dig a foundation of 36 feet long, 21 wide, and 9 deep. All right, so we've got a rectangle that's deep, like, in the ground. All right, so we got a 3D shape going on here. All right, something like that, so that you can have an opinion. Okay, 21, 36, and 9. All of them are in feet. The contractor pays, so this is a rectangular solid. All right. Then it says $10 per load of truck to remove the dirt. All right. Each truck holds 9 cubic, that means to the third power, yards. All right. What is the cost for the contractor to have the dirt hauled away? Okay, so they're digging a rectangular solid in the ground, a hole. All right. So understand the shape involved. We know it's a rectangular solid. What formula? Formulate a concept to answer the question. Okay, well, we've got a problem here. We have yards squared, and this is in feet. So we need to convert feet to yards first. Then calculate surface area. That's our process. All right, so here we go. Actually, we need volume. Sorry about that. Not surface area. They only ask for volume because that's how much dirt. Sorry, I wasn't thinking properly. All right, so let's construct the problem. So our first thing is 36 feet, and we know 3 feet equal yard. And then we have 21 feet, 1 yard. And last one is 9 feet, and 3 feet equal 1 yard. So what happens here is that okay. What we have here is that the feet cancel and we end up with yards. And there we go. So now we're going to do the math. And I'm going to have 3 divides 36 12 times. So we're going to have 12 yards. And you can use a calculator. 3 divides 21 7 times. We have 7 yards. 3 divides 9 3 times, and we have 3 yards. So now we want volume. Okay, so now we're going to construct a problem. And there we go. So our volume is going to be, sorry, 12 times 7 times 3. All right, so we're going to do that in our calculator. All right, so I'm going to have the 12 times 7 times the 3. 252 or cubic yards. All right, but now we want to know cost. We know that it's $10 per, okay, per 9 cubic yards they charge. All right, so we're going to multiply that by the 352 yards cubed, and we know then that we're going to end up with money because this cancels this, and we end up with money. Okay, so we can do several things. We're going to multiply and divide. So that's what we're going to do because we got a calculator. So we're going to have 10 times that. And we're going to stick that in our calculator. Could do it in pieces. In other words, we could have divided the 352 by 9, then multiply by 10. Doesn't matter which way you go, it's going to come out correct. And I need to make sure you know. And they're going to be what? And it'll probably say how many dollars. All right, so let me move this over here. And this is in dollars, $391.11, or approximately $381. You answer the questions on the computer the way they want. They will tell you if they want cents or if they do the dollar. And we would say about $391. A good question, isn't it? All right, so now we're talking about one last problem for this lesson. And this is a water reserve is shaped like a rectangular solid. Again, we've got a base with 60 yards, 20 yards, and a vertical height of 30 yards. Of course, my drawing is not up to scale. All right. So we know that this is 30 yards is the height. This is the width. This is the length. It's a rectangular solid. All right. So the shape is rectangular solid. Formulate a concept. What do they want? Okay. At the start of a 3-month period of no rain, the reservoir was down 4 yards. How much water was used in the 3-month period? Now, it's saying it was down 4 yards. Okay, so we need volume of full of water in the reservoir. And then we need the volume of the height equal 4 yards. And then we're going to subtract them to find the amount, how much water was used in the 3-month period, because it is down to that amount. So this is what is used, what's left, what was evaporated from the of no rain. So here we go. So we're saying the volume of the full minus the volume remaining equals the volume used in the reservoir. All right, here we go. So we are saying C times 20 times 30 minus 60 times 20 times 4, because that's all that's left, equals volume used. All right, so that's a calculator. $60 times the 20 times the 30 minus 60 times the 20 times the 4. So I make sure I double check. I'm sorry. 31,200. This is yards cubed. Was used on the reservoir because there was no rain. All right. Now you can do the homework, and I would suggest you do. Thank you very much for listening.